Okay. So welcome once again to another video on matrices, and then we may go into determinants. Then by the end of this video, you're going to understand how to solve matrices, determinant, and then inverse of matrices. Now, basically, what's a matrix? A matrix is just a set of numbers arranged in a rectangular pattern and enclosed in a bracket. So, for example, uh, we have, right? You have a particular numbers like, let's say 6, 5, 4, and 2, right? Now, so these, since they are enclosed in a bracket, we call those matrices. Those That's a matrix, right? So a matrix is just any set of numbers that are arranged in a rectangular pattern and enclosed in a bracket. So next, we are going to talk about order of a matrix. Order of a matrix can be of order n by m. A matrix can be of order p and q. Don't get confused. All it really matters is that you're talking about the row and then the column, right? You're talking about the row and the column. So a matrix can be of order m by n. That's to tell you that it has n number of rows, then m number of columns, right? Good. So for instance, if you have a matrix that has 3 rows and 3 columns, then you can say that the matrix has m number of rows and m number of columns. M number of rows and m number of columns. So for instance, we have this matrix here, 6, 1, 2, 3, then 4, 5. Then clearly it has 1, 2, 3 row. So it has 3 rows. And then we'll count the number of columns, 1, 2. So it has 2 columns. Good. Now you can talk about it as having 3 by 2 in dimension. So now this is talking about the dimension of that particular matrix. So next we are going to talk about here is the notation. The notations that we have. We normally indicate a matrix with capital letters A as a matrix containing maybe 1, 2, 3, and 4. Now, because of the fact that the row is the same as the column, we call this a square matrix. A square matrix, right? So it can be 3 by 3. The dimension can be 3 by 3. For instance, 0, 1, 2, 3, 4, 5, 6, 7, and 9, right? Now, we always talk about matrix in row and column. So matrix A, if I want to list the element using the concept of subscript, I can have the element in small letter 1, 1, then A1, first row, second column, A second row, first column, then A of second row, second column. I think this is very straightforward. And then we can have another example. We have matrix B, which now has element B1, 1, first row, first column, B1, 2, first row, second column, B2, 1, second row, first column, then B2, 2. Now, similarly, I can have matrix C. Now, let's make this 3-dimensional. So we'll have C1, 1, right? So we'll have C 1, 2. So we'll have C1, 2, first row, second column, then C1, 3, right? Good. So we'll have C2, 1, C2, 2, C2, 3. Lastly, we now have C3, 1, first row, third row, first column, C3, 2, third row, second column, then C3, 3. I think it's pretty straightforward. Now, quickly, we're going to talk about how can we have some operation done in matrices. Now, we're talking about the operations in matrices. Operation. So we have matrix addition. Addition, we have subtraction, right? Subtraction. Now, we subtract them using the elements in the same position. So A11 is going to be added to B11. A12 is going to be added to B12. Similarly, A21 is going to be added to AB1. Then A22 is going to be added to B22. So for example, let's look for example. For example, we have this matrix here. If matrix A is going to be 4, 0, 1, 2, and the matrix B, if we have matrix B to be like 1, 2, 3, 4, good, then A plus B is going to be 4 plus 1, 4 plus 1, 0 plus 2, right? So we have 1 plus 3. Then lastly, we have 2 plus 4. So your final answer is going to be 5. 5. Then here we're going to have 2. Then here we're going to have 4. Then here we're going to have 6. So that's what we're going to have. Then similarly, if it is subtraction, we're going to do the same. The same. So lastly, what do we have next? Now, we have the fact that we can add a matrix. So we go straight to how to multiply a matrix. How to multiply a matrix. Now you multiply a matrix row by column, row by column. Similarly, for a 2 by 2 matrix, let's pick a general form. We have A11, A21, A12, rather, pardon, A21, then A22, right? Always consider the row first before the column. So we have B11, we'll have B1, 2, then we'll have B21, and then B22. Now I want to multiply these two matrices. We're multiplying based on row. We take all this row that is here, multiply by this column. Then for the second time, we're going to pick this particular rule again, then multiply by this guy here. So first of all, I'm going to start with the first one. Take this rule and multiply by this. We'll now have A11 multiplying B11, then plus A12. A12 is going to multiply B21 here, right over here. Good. Then for this part, it's going to be what? The second time, I'm going to still multiply row by column. I want to get the element in the first row, second column. So I'm going to take the first row multiplied by the second column. So I'm going to have A11 multiplying B12, which is now the second column, then plus, I'm going to have A12, then multiplying B22. Now this is pretty straightforward. Then I'm going to now, I want to get the element in the second row, first column. So I'm going to take the second row and then multiply the first column. So in this case, what are we going to have? Let me use a black one. So the dark one will have A21 multiplied by B21, then plus, I'm going to take it again, multiplying the second one. A21 multiplied by B11, then we have A22 right over here, multiplying this element, B21. Good. Then lastly, I'm going to do I want to get the element in the second row and second column. So I'm going to take the second row, multiply it with the second column lastly. So here I'm going to have A21 multiplying A22 plus A21 multiplying B12. Pardon, A21 multiplying B12, B12. Then I'm going to take A22 to multiply the last element there, which is A22 to multiply B22. And you can always check if your multiplication is accurate. Check this should match. This element should be the same. The second element should always be the same. Then this element should always be the same. Now, quickly, if you can take, let's take an example, a straightforward example. For instance, if I had A to be equal to 3, 2, 1, 2, and we'll have B to be equal to 2, 3, 1, 3. Now, simply if one multiply A multiplied by B, what are we going to get? We're going to get 3 multiplied by 2, 3 multiplied by 2, then plus 2 multiplied by 1, 2 multiplied by 1, right? We're done with this part. We're looking for this element now. First row, second column. So I'm going to take first row multiplied by second column. So I have 3 multiplied by 3 plus 2 multiplied by 3. 2 multiplied by 3. And I'm coming to this element, second row, first column. Second row, first column, right? So I have 1 multiplied by 1 plus 2 multiplied by 1. 1 multiplied by 2, rather. 1 multiplied by 2 plus 2 multiplied by 1. Then lastly, 1 multiplied by 3. 1 multiplied by 3 plus 2 multiplied by 3, right? So clearly, we're going to have 6 plus 2. Here we're going to have 9 plus 6. Here we're going to have 2 plus 2. And here we're going to have 3 plus 6. So our final answer is going to be 8, 15. Then we're going to have 4. And then lastly, we're going to get 9. So I think it's straightforward. You can do the same for a 3x3 matrix, which we're going to do after we have listed some of the types of matrix that we have. Now you can add matrix, you can subtract matrix, and then you can multiply a matrix. Now quickly, let's talk about some types of matrix. We have the zero matrix, the matrix of zeros, zero matrix, and how does it look like? Now, is any matrix that is of the form 0, 0, 0, 0. Now, this is for a 2x2. Now, for a 3x3, is going to be appearing as 0, 0, 0, 0, 0, 0, 0, 0, 0. Right? This is straightforward and this is simple. Good. Now, we now have another type of matrix, which is a square matrix. We have talked about this before. Now, a square matrix is a matrix that the dimension is the same, right? The dimension, if a matrix has 2 columns and 2 rows, or a matrix has 3 rows and 3 columns, then you say it's a square matrix. For example, you have A, B, C, and D. This is a 2x2 square matrix. And similarly, this is also a square matrix. This is also a square matrix because we have 2 rows and 2 columns. So we also have a diagonal matrix, a diagonal matrix. Now, a diagonal matrix, it has elements only in the diagonal. For example, if there's a 3x3 matrix and you have a matrix looking this way, 0 elsewhere, only in the diagonal, you have elements, then you say that is a diagonal matrix. And this is called the leading diagonals, right? Now, if for instance, you have a matrix where the leading diagonal entries are 1, and then the diagonal elements are just 1, then this matrix is what we call the identity matrix. The identity matrix. It has some unique features. If you multiply this matrix with any other matrix, you are still going to get that matrix. So this is for 3 by 3, and a 2 by 2 diagonal matrix is going to look like 1, 0, 0, 1. Good. Now, similarly, we are now going straight to how we can obtain a, we have other matrix like upper diagonal matrix that are skewed. Upper diagonal, you have entries on the upper diagonals, right? But you have 0 on the lower diagonals. There are so many kinds and types of matrix rather that we can discuss later. But for now, we're going to jump straight into matrix determinant. So I guess we can do, let's me use one example for addition to see how we are familiar with addition. If we have this matrix 2, 1, 2, 4, we have B to be equal to 1, 0, 2, 1. Then we have C to be equal to 2, 4, minus 1 and 0. Now I can say, well, let's have A plus B, then minus C. So we are going to treat this first so that we get used to addition. So A plus B is going to be what? 2 plus 1. So we have 2 plus 1. Then we can do minus C automatically, which is just going to be minus 2, which is straightforward, right? Then we'll have the next entry here now will be 1 plus 0, 1 here, plus 0, then minus 4, minus 4. Then we have 2 plus 2, 2 plus 2, minus 1. So we'll have minus into minus 1. Then we have 4 plus 1, then minus 0. So this is straightforward, right? So we're going to have 1 here. We're going to have minus 3. We're going to have here 5. Then lastly, we're going to have here what? 5 also. Good. So this is for a 2 by 2 matrix. We can go further to do it for a 3 by 3 matrix. Now, a condition for multiplication. If you have two matrices, A and B, and I want to multiply these two matrices, I have to consider first the column. I have to consider the column of matrix A. Take it that you're considering the column of matrix A and then the row of matrix B. Now, the column of A must be equal to the row of matrix B. So just intuitively, just take it as like the tail of the first matrix should be the same as the head of the second matrix so that they can connect. So if I have the dimension of matrix A to be 2 by 3, and I have matrix B to be 3 by 3, I can multiply these two matrices because I have the column of A to be 3 and then the row of B to be 3. Another example, I have 3 by 1, then I have 2 by 3. Can I multiply a matrix of this kind of dimension? I will consider the column of A and then the row of B. Since they are not the same, I can multiply these two matrices. So for instance, I have this matrix 3, 2, 1, 3, 2, and 1. And I multiply it with a matrix given to me 1, 2, 1, and 2, 1, and 3. Can I multiply this? Now let's consider this has a dimension of 1, 2, 3 rows. So I have 3 rows. 3 rows by column, 1, 2 column, 2 column, right? Why this has 1, 1, 2 rows. So I have 2 rows by 1, 2, 3 columns, 3 columns. You can see that the column of A of this initial matrix here is the same as the row of this matrix. So we can multiply this. So let's try. Multiplication, we're going to take the row to multiply the column, right? So here, for this, we're going to have 3 multiplied by 1, right? Then plus, we're going to take the last element 2 multiplied by 2. So we have 2 multiplied by 2. Good. We still take the first element, multiply by the second element until we are done with all the columns here. So we have 3 multiplied by 2, which is here, then plus 2 multiplied by 1. Then we're going to take it again to finally complete that first row. So we have 3 multiplied by 1, right? Then we have plus 2 multiplied by 3. Good. So we now go to the next, which is this. The next row, which is this, we now have 1 multiplied by 1 plus 3 multiplied by 2. Let's be fast. We now have 1 multiplied by 3, 1 multiplied by 2, right? Plus 3 multiplied by 1. That's right. So we now have, lastly, 1 multiplied by 1 plus, we now have this 3 here multiplied by this particular 3 over here. So we have 3 multiplied by 3. Then for the last row, we now have 2 multiplied by 1 plus 1 multiplied by 2. We take it again, 2 multiplied by 2 plus 1 multiplied by 1. Then lastly, we now have 2 multiplied by 1. This 2 over here multiplied by 1. Lastly, then plus, we now have this 1 multiplied by this 3. You see, 1 multiplied by 3. So it's straightforward. So because we have, here we're going to have 3 plus 4. You're going to have 6 plus 2, right? Here we're going to have 3 plus 6. Then here we're going to have 1 plus 6. Here we're going to have 2 plus 3. Here we're going to have 1 plus 9. Here we're going to have 2 plus 2. Here we're going to have 4 plus 1. Then here, lastly, we're going to have 2 plus 3. Anybody can do this. Anybody can do this. This is just straightforward, right? This is just straightforward. Anybody can do this. So anybody can evaluate this. For this, we're going to get 7, right? 7 here, 8 here, 9 here, 7 here, 5 here, 10 here, 5 here, 5 here, then 4 here. And that is that about that. We are done with that. Now, there can be a very familiar concept that we should know about matrices. And this is the concept of what we call a transpose. A transpose. Now, what is a transpose? A transpose is just taking the role of a matrix to become the column. So for instance, quickly, let's just pick, learn by example here. We have a matrix here, 4, 1, then 5, 0. If this matrix is matrix A, then the matrix A transpose is going to be, I will take this row and change it to become the column. So I have 4 and 1. Then lastly, take this to become the next column. So I have 5 and 0. So this automatically become matrix A. So for a 3 by 3, let's say the dimension is 3 by 3. Let's look for one example. We have 2, 3, 0, 1 minus 1, 6, then 4, 2 minus 3. Good. So we have this matrix. Let's call this matrix C. Therefore, matrix C transpose is going to be what? We take this particular row and make it the column. So we have 2, 3, 0, we have 1 minus 1 and 6. Then we have 4, 2 minus 3. Then lastly, we are going to talk about the determinant of a matrix. The determinant of a matrix. What is the determinant of a matrix? What is the determinant of a matrix? Now, the determinant of a matrix, to obtain it is very, very simple. How can I obtain the determinant of a matrix? For instance, let's solve using this particular matrix over here. So we are now in determinant. Determinant of a matrix. Determinant of matrix. If it is 2 by 2, in our case, we have A is equal to 4, 1, then 5, and 0. So the determinant, we can have it written as this. Determinant is the same thing as determinants of matrix A. So this is just going to be 4 multiplied by this element, the leading diagonal multiplying, then minus, we now multiply this and this. So we're going to have 5 multiplied by 1. Good. So this becomes our determinant. So here we're going to have 4 minus this multiplied this is 5, right? So we have that, and it's very straightforward. So we're going to have 4 minus 5, which is just minus 1. Good. Now let's talk about the determinant of a 3 by 3 matrix. So if it is 3 by 3, 3 by 3, determinant of a 3 by 3 matrix. Now let's pick, for example, we have A11, A12, the generalized form, A13, right? So we have A21, A22, A23, we have A31, A32, and A33. Now we are going to take in consideration the minors of this matrix. But for instance, let's me use this particular row to get the determinant of this matrix. You can use any of the row, but bear in mind you have the sign to follow, like we said in the previous class. So minus, then this is positive, minus positive. You can check the other videos, the previous videos. You can check them for clarification. So if I want to take that first row, right, I'm going to write A11 together with the sign. If I'm taking this row, I'm going to take the negative. So once I consider using this row, I'm going to strike it out like this. So for this A11, right, we're going to have this particular guy taken out. We're going to be left with 2, 2, A23, A32, and A33. For this second element, I'm taking out this guy and this guy. I'm going to be left with this. Taking away the sign, have minus A12. So we have A21, A23, A31, and then A33, right? And plus A13 into what will be left. If we take out this guy, we're going to be left with just here. So we're going to be left with A21, A22, A31, and A32. And everybody can now do determinants of this. This is very straightforward. We can now do determinant of this, which is just this multiplied by this, and then this multiplied by this. So this is a general form. In the next class, we're going to be taking some more examples. So you have A22 multiplied by A33 minus A23, then multiply by A32. When you're done with this, then go to minus A12 into this multiplied by this, A21 multiplied by A33 minus A23 multiplied by A31. Then lastly, you have the plus A13 multiplied by A21 multiplied by A32 minus A22 multiplied by A31. It's straightforward. So we'll do some examples in the next video. Thanks, and let's watch us for the next video. You should please subscribe. Thanks for watching. See you in the next class.